Good morning everyone. In this video, we are going to learn about RAID. RAID is a redundant array of independent disk. Because of this property, it is also part as inexpensive disk. Actually, there are 7 basic levels, out of which 6 levels are in common use. These all levels are not an hierarchy. They are independent of each other. So, whenever we want to recover the data using RAID methodology, any of the RAID level can be incremented. That is the reason we say them as independent levels. So, this set of physical disk drive viewed by the operating system as a single logical drive. That is, even though we are having separate this physically, the operating system will be looking them as a single drive. The data are distributed across the physical drives of an array. Whatever we want to store in the system, they will be stored in different disk drives. The redundant disk capacity is used to store parity information, data recoverability. So, redundant disk capacity, in order to store some redundant data, we required some extra disk. This redundant data will helping us to recover the data when there is a damage or loss of data. So this RAID actually improve access time and improve reliability. The first very basic level is RAID level 0. Actually, this is not considered as one of the RAID level because no redundancy will be incorporated in this. One single logical disk, what we are seeing from strip 0 to strip 15, will be divided into 4 physical disks, 1, 2, 3, 4, in a round robin method. So, this distribution of data from logical disk into physical disk will be carried out by a management software. So, the round robin method, it means first step 0 goes to physical disk 0. Step 1 goes to physical disk 1. Step 2 goes to physical disk 2. Step 3 goes to physical disk 3. And now adding step 4 goes to physical disk 0. Step 5 goes to physical disk 1. And like this it continued until all the steps are mapped into one or two other physical disk. The next is RAID level 1. In the RAID level 1, redundancy will be the highest level because whatever the data disk we are having here will be replicated as it is. So this is called mirroring method. So whenever we want to read the data, it can be read from either of the disk, either of the original disk or the duplicated disk. We can read the data. So this will be helping us for shorter queuing, and also rotational delays will be very less. At the same time, seek time will be very less in the case of RAID level 1. The mirroring method, that is RAID level 1, will be used in the case of application where we require more availability and transaction time should be less. But Storage is not a problem. That is, cost efficiency is not a problem. It can be more cost also. It requires both lists to be updated. This can be done in parallel. So when you are writing or updating a particular strip, let we say in strip 8 has to be done in both disk. We are doing in both disk. So because we are doing that in parallel, it doesn't matter. Reading can be done from another of the disk. Suppose if I want to read strip 4 and strip 8, it can be done in parallel. Even the strip 4 and strip 8 are in the same disk actually. The disadvantage is the cost, and it requires twice the disk space because all the data we are duplicating it. So the rate level 1 improves the read request. Actually, when both disk members participate, that is, as we already specify, if these both are participating or both are participating in the disk reading, then it will be more advantage. Yes, this is the very basic advantage when compared to all the other rate level in the case of rate level 1. Now coming to the rate level 2. When we see the rate level 1, we can see that the requirement of space is more number of disks are required. So in order to reduce that, cost bit level stripping is introduced and Hamming code is introduced in the place of mirroring method. So the redundant data is meeting using Hamming code method. So if you see here, B0, B1, B2, B3 are data disk. Has not be F1B, F2B are the redundant disk. So whatever the bit we are having in the particular position, have B1, B0, B1, B2, B3, and the Hamming code will be found, put into F0B, F1B and F2B. Bit level stripping is nothing, but we are having a 4-bit data. First bit will go to B0, second bit to B1, third bit to B2, fourth bit to B3. This is called bit level stripping, and easily we can rectify the data whenever a particular disk is failed. So when a particular disk B1, particular disk B1, let us say it failed, then in that case this can be recovered from B0, B2, B3, F0B, F1B, F2B. In this case, in the case of RAID level 2, we need multiple redundant disks. That is, all the disks we need identify whether a particular disk is failed or not, but we need only one disk in order to recover the last information. How is this? We will see it later. Thank you.